So thank you so much for your time. Thank you, Ernest, for coming
I wouldn't miss
all the
it.
time.
I wouldn't miss it, my friend.
It's a honor,
Salam alaikum.
salam alaikum, being, your friend and a lot of language we need, to learn from you, man. So thank you so much for your time. Thank you for having me, here. We are the 0 to 1 technology, ZT1 technology. We will tell you some story about who you are, what we do, and where we are going. I came last time, with the professor here, and I get great tour. So I really appreciate it, and we want really to build a long, collaboration partnership in future. So we want to share with you today some, with everything happening in the world, from aviations, electric aviations, sustainability, decarbonizations, everything, happening for the vehicle, from the space, aerospace, from the new geopolitics now, new administrations, past administrations, the futures, and what we are expecting for some trend in future, right? So and we will keep maybe a few minutes to discuss, ask questions. It's better, to provide specific, answers for maybe what's either for you, for your kids, for your partners, for wherever, what will be the next, big step coming, specifically in this country, but, all over the world, right? We call it sustainable aviation insight, trend, and leadership lessons. Why leadership lessons? In reality, we'll see through the presentation that we have taken a bold move in our life. Getting to my 50 years old, I said maybe it's enough, and I have to do something meaningful in my life. That's why I start this journey, and we are starting really from $0, zero everything, and we want to create a life, a book in our life to see if we give the same rules, the same key to people, whatever the age, what will be the steps they need to follow to to be the business. And this presentation is exactly with that. We are merging as well with what's the with the trend of what we are looking and what looking to achieve during the next 2 or 3 years. So I start all the time by this one. It's a formula. I was used to, in the past I visited, Harvard, and, one of the professors, he put this, and I was impressed about, the formula. And in reality, it's applied a lot on what we do on our life, and as well the decision we're going to take. It's, I think, by the end of the presentation, we will give, what's that stand for, the H equal L to E. And it will really measure your, everything, you do in your life through this formula. It's not a differential, integral, formula, but it's absolutely simple thing, to do. Very quick, we're gonna go through a brief introductions, who we are, what we do, some trend, ZT1, what is the ZT1, technology, what we are doing. And of course, from the aviation and what happening, in this beautiful country, what we are doing, what we are expecting, what's the difference between some others, other sectors, doing electrifications as well. And we end up with some lessons learned from what we have achieved and how we can see the next, move. I don't know if you see this here, but a very quick executive summary. We are a B2B business, 0 to 1. We address, to businesses. We are focusing on connectivity. Specifically, we are not only aerospace. We are starting a focus to do aerospace. We will see what are the sector there, what is the market segment, but we are looking, to extend to, to other market in future. We are offering, advanced, hardware and software, and we will give you, some key when you do the hardware for. And you start a business doing a hardware, what is going to take in terms of capitals and, compared to just launching a software. So that kind of stuff we do, and we will see, that product. We are looking for a total addressable market only for products like, beyond 300 billion business, not counting, the aircraft and, and the mobility, but just, from the product perspective. And the goal, you will hear that, by 2028, we want to be tier one supplier for electrification. And it's a bold decision, bold goal, like, to be honest with you. With every uncertainty, now, it's crazy to claim this, but we are making it as a goal. So our mission, our vision first is connecting, communities through clean, accessible, affordable, and equitable air transportation through electrification. So meaning, like, we want really to connect communities, that first. Second, through electrification. And we will see what are the other technology we can, connect communities, but this is what we are aiming to. We are the generation of hardware, software, now AI coming in more. So we want, really to explore, like, all the, the way from power electronics to electric motors to batteries to fuel cell, whatever. And we want, really to connect the communities through. Now, what's the start point? That's what we're going to see, during these presentations. And the mission to do our vision, this is important. Why we are doing this? Because when you launch your startup, your business, in reality, like, from investors and stuff, like, what's the mission, what the vision, what the mission, and you connect this, and they will in reality, like, check your progress and how much you are deviating through that, from the beginning when you said that. Reality is, since we started like 1 year and 2 months, we are absolutely not changing any word, which is great, awesome. And we are achieving our vision by delivering, like, advanced electrification technologies through innovative hardware and software. So we are mainly product people. We design, we produce, made in the United States. And as well, empowering, and this is important for us, empowering, businesses worldwide. And what the link between, you build the airplane, but you are empowering, other businesses, and you will see it. And we are empowering not only, like, our suppliers, because this is a must. We have seen, Boeing doing this in the past, but Bombardier, they are very, very good on empowering, supplier and investing on their suppliers. And we have seen maybe some issues in the past with the 787, where a lot of suppliers and doing, some work there. So how you can lose the momentum of them. So that's what we do, and we want, to achieve. But we are doing with another angle. So we're gonna give you some, some keys there as well. If you launch, your business one day, and that's the aim of this presentation, is to give you the, the desire to do that, to do so. Very quick, like, this is, much more for, like, for the electrifications, starting at, like, in Europe with Liebherr Aerospace. It's almost like, it's a tier one supplier for Airbus in reality. The competitor is Honeywell, and we at Liebherr, we provide, like, the air conditioning, so we provide the pressurization of the cabin. We provide, the flight control. We have done, like, everything related to, to system you can see, in the airplane. And we have done a lot of electrification at the time. So we did, like, flight test for what we call the electric ECS. So you remove, the pack, which is, the air coming from the bleed. You suck, the air from the engine. You go through different, conversion of, like, through heat exchangers and, compressors and turbine, and you send that air, to the cabin. And in reality, we remove that, that bleed, and we put, like, electric motors, electric compressors. So in reality, we start power electronics software at that time. In France. After that, I joined, Magni-X. A lot of, work there, a lot of flight tests, from the Beaver to Caravan. Everything we in Magni-X was, like, almost like, the first ever worldwide electric airplane. Like, for example, like, the Beaver was in 2019, 350 kilowatt. It's the aircraft full of batteries and power electronics, electric motors, flying that airplane. After that, we repeated in Moses Lake. And the story going, went through different, flight tests. But the most important, piece on that is how you create what they called that time the Bible, meaning if you want to create any technology or create an aircraft, you have to have a set of requirement from the FAA. So all the existing airplane, they have your set of requirements set since maybe 100 years. But when you do electric, you do fuel cell, you do hydrogen, you have to have a new set of requirements. And we call them like a sort of deviation, a special condition to do that kind of stuff. So we worked on the special condition, and this can happen for age for anyone, maybe one times over 100 years to work on that kind of special condition, because you create the Bible. And after that, you give that Bible to the worldwide, so they can use it as a reference, and they have to create their own, special condition. Since, 2019, there is no special condition was created for anyone in the world so far, from Joby to Beta to whatever it is for aviation, for anyone, until, today, because it's a lot of work. After that, I went, to Amazon, for where I was leading, how we call it, the propulsion system and the battery department there. Great, a great company and a great, kind of, philosophy and culture. And end up as well, as a chief technology officer at Zero Avia, where we moved from the battery in my life to the fuel cell, because I wanted really to explore that aspect. What's the difference between powering an aircraft through battery and through fuel cell? And of course, when you get to that environment comparison between the both, in reality, you are exploring much larger, power source, the SAF and, other technologies to compare, to find real, a real value. And in reality, we put the boundaries there. By 2023, I left, the Zero Avia and I started the 0 to 1. And reality, it's come, I was flying to the UK. One of the professor in Georgia Tech said, "Hey, Dr. Youcef, you need to read this book." Take, the book, take the plane. I was reading the book, and it's called, 0 to 1 from Peter Thiel. And I just learned, I read it through the 10 hours, and I said, I know what I'm gonna do. I'm gonna be starting a company. Because everything we do, the question you are asking yourself now is, what I'm gonna be doing tomorrow? Of course, going to the big companies, learning, doing new things, earning money, or creating, an impact in your life. It's a lot of questions. And before you get to the real what you want to do, it's gonna maybe sometimes take 10 years. It's last year I was 49, so I decided, to start something, from zero, from scratch. That's what I'm doing, today. And of course, I am part with Ernest here, a great foundation, to give from our time as well, to Ernest and his foundation, to continuing as well, much broader, I would say, aspect in terms of what will be the energy of tomorrow, and how we combine the energy, all that kind of energy to create a sustainable, future for our kids. So this is what the foundation is doing, and a lot of great people in the team,
Including yourself.
including the boss. So what's the problem? What we are solving in reality, what we are doing, right? In reality, there is, very quickly, I will summarize here, and you can quote me in the numbers. But definitively, you can go from this room, by 2050, 30, 50, there is much more people flying airplane than today. It's gonna be even double. You want to do nothing. And all the civilizations, all the countries the middle class is growing. They're getting access, to much more, people, want, to travel with your family. So, and all the aircraft, flying today, they are 20, 30, 40, 30 years. So what we're gonna see, a huge, air traffic, increasing. And if we compare the aerospace, like, space, I would say, it's gonna be like, a big factor from the emission. And that emission, we can compare the CO2 to no CO2 emission. Like, from the impact perspective. And that, like, the both curve are growing in the same time. So there is a lot of numbers around, like, what will be, but definitively we are not, like, close to 3%. We are even beyond 20%. So it's by 2050, it's gonna be like, usually you have less aircraft. The big airport, like, you can spend 5-6 hours, in the gate. Unfortunately, a lot of accidents gonna happen more and more and more, because a lot of people, they build aircraft, they want now to retirement, they're enjoying their life, and we didn't do everything, like, to maintain, that generation, to maintain the airplane, and we don't have a new airplane. So even like, the disruptive, I would say, plane we have done in the US was the 787. And if you see the people doing the 787, they are all of them retired today, and it was the more electric airplane. And in reality, like, a bit surprised that I've never seen that people doing, the VTOL today, which they have to, because they can bring a lot of experience they have learned from, the 787, which is a beautiful airplane. So emission increasing, air traffic increasing. I will not say it's a bit of heavy image, but it's we need, to work today, and a lot of people start, really working on this aspect to create, like, something much more meaningful. US is a big country, and compared to others, in reality, there is, like, there is a lot of aircraft, a lot of airports, sorry. And we can count like more than 10,000, 20,000 airports. Compared to, for example, Europe, which is the entire Europe where I'm coming from, there is 1,000 airports. Here we are talking about, 15, 20,000 airports. And what happened during the last 10, 15 years, that the big, like, airlines, they figured that it's physics, but it's economics as well. More the aircraft is big, more you have much more margin. More aircraft is big, the airport is big. So where we are going, we are pushing, people to go to CTEC, spending 45 minutes in traffic, getting, 2 hours there to the gate. A lot of people dropping there, to go everywhere, national, international stuff. So for door to door, like, for 10 hours flight or 1 hour flight, it's almost the same. So and that's like, it's creating a lot of conjunctions, a lot of, like, a lot of, issues. And what we are doing when we are doing this, we are absolutely killing the original, like, airport. Small airport, like, close to you. If you look just around, like 15 maybe miles around you, you will find like a regional airport. So that airport, in reality, they are not like, some of the airport, they are at $1 in reality. They are selling, the airport to $1. They are like, this is coming from the from the NASA staff. It's data. We have more than 5,000, between 5,000 to 10,000, maybe airport underutilized. A lot of budget from the state to to the small airport. Hopefully, the Dodge will not go here. There is 1.6 of all trips, like between 50 to 500 miles, taken by air, and you have 20,000 airport, I think, and you have 1.6. It's crazy, right? 0.6 of the US airport are currently, like, using 70% of, like, air traffic. It's crazy, and you can find that, like, that numbers to see where we are going, reality. So the great infrastructure, the air traffic is increasing, the emission are increasing. So what do we do? There is a moral stuff, to do that. But if you are, like, thinking business, like, really, there is a big business as well. So you can create, like, the moral aspect with business, earning money, creating a better future for, for the new generation. That's what we do. So this is like, we started to look to the data in the United States, and we say like, if we have 20,000 airport, and how the people commute, here, compared to the worldwide. And in reality, when you see, I put like, up to 500 miles, but because we're going to small airports, so small aircraft, how the people commute here? We are designing for this kind of country because the infrastructure is here. We found out like, less than 100 miles, it's 8%, 8% is happening under like, 100 miles, 40% less than 300 miles, and 65, 70, 75 under like, 500 miles. It's a fantastic, like, place to be. And if you compare to worldwide, we reverse like, the trend. People are flying, worldwide, transatlantic, much more bigger distance. The airport, they don't have much more airport, so they are not flying, nationally. Here in the US, the mapping, the economic economic like mapping, it's great that anyone can take an airplane for 1 hour flight, and even it's like a 320. So because it's economically, great. So the short haul flight dominate the air travel. And we found out that the electrification to solve all the things we are saying, the electrification is the best way, to go. So emission and all the things. So we addressed some solution. We said like, what can be, of course, we are not doing it, and we didn't want, to do it, but just we want, to compare. Of course, there is batteries. There is, you can see worldwide, like people are talking about, electrification of the turbine. You take the HP or RP and you make like electric motor there. Of course, the SAF, biofuel or synthetic fuel. In reality, there where like, you will see there where the tendency is going more for different reasons. Of course, burning, hydrogen, and you can see now, like, what is the where is the place of hydrogen coming, and where we are going. In reality, it's a great, like, energy, and of course, like, the fuel cell. So the trade I put, very quick. The trade, all of them, to choose, choose between them. There is a cost, efficiency, incremental maintenance, the scalability, and and really truly zero emission or no. Sorry. I put this table, sorry for maybe like, small, but what we have done, I put like, toward 2026, 2060, the trend of like, the technology. So very quick, we split it between the numbers of seats, like, two 5-seaters up to the 250, and, for the long haul, the commuter, the regional, the short haul, and the medium haul. And we gave like, what will be the technology along the, the way, So from 2020 to 2050, right? Small airplane, dominance is going to be batteries, right? Commuter and regional, we will be starting with, with batteries, but very quick, we will introduce, some hybridizations because the batteries are limited in terms of weight and maintenance and, whatever you want to stop. So much mainly we are putting, much more fuel cell and hydrogen there. And more the aircraft is big, more the SAF is dominant, the dominance of the SAF today, but more we go, more we'll be moving, to hydrogen. Why? Because when you see the synthetic fuel, the biofuel is not, is not possible. Like, we cannot, commute, or we can like, just leave, because, there will be like, issue of, economic issue there, but as well as the model. Synthetic fuel, in reality, what you see, if you prepare the installation of the synthetic fuel, which is happening today, and somehow you have to capture the CO2, but you have to create the hydrogen. So during the process of the synthetic fuel, making hydrogen. So somehow, like, the technology fuel cell or burning hydrogen is growing, and there is an infrastructure preparing, the hydrogen. And somehow someone, like we said, I don't care about like, producing the SAF. I'm going to take that hydrogen. My technology is working now. I can pull up the hydrogen to, to my installation. That's why you can see by 2060, more the aircraft is big. We start with the SAF because it's a very intermediate solution. But after that, we move straight forward, to hydrogen by 2050, 2060. Right. So just to remember, a battery, fuel cell hydrogen, of course, SAF for the big, and after that, when we move, we will end up doing hydrogen future. There is an infrastructure discussion today and how much capital we put. But as we said, there is no magic solution by 2050. We have to work today, and aircraft is 30 years. If you're Ernest can tell you, if you design an aircraft today, it's 8 to 10 years, and after that, you will live for 32 years. And no one will take a decision or risk to design an aircraft, and even make an amendment or STCs on airplane. What is our approach? It's ZT1 on all this. It's I call it pragmatism. Start small, create small airplane, create our core technology, sell that on the way, core technology to bring cash, inject that cash for our two-seater airplane, and we're gonna end up by delivering the low cost, practical, and seamless door-to-door air travel experience. And in reality, we are starting really, really small. We are starting with the two-seaters, four-seaters airplane. From the economic perspective, they can tell you, you can find a bunch of people just what the economic around that. And I'm saying, I don't care. What we care is we have a fantastic infrastructure in this country. You have a small airport to small airport. You put two-seaters, five-seaters people that will travel. And everything we have said about the big airport, we're gonna just it's gonna go away. So meaning if you want to travel to California, you take maybe 2 airplanes and you are in California. Cheaper, clean. You don't have all that waiting stuff. You can fly with your family, and it's doable with the technology today. And I will tell you why. In reality, that when we started, and more we go on that strategy, we found out there is a lot of need. And my son is Civil Air Patrol, 14 years old, and he's flying 172 Cessna. And we were talking with the people there. They said, if you have electric airplane, we'll buy it today, because we have an issue of shortage of a pilot in future. We will have less aircraft flying. The park today of the aircraft, it's old, at least 40 to 50 years old. The aircraft are not efficient. If we have an electric airplane, cheaper and as well clean, we can absolutely use it today. And it's absolutely economically speaking, it's the right visit. Of course, we are end-to-end solutions. We design everything in-house. It's a bold stuff. So we start small with the Bryce here, which is the VP of electronic systems. This is, for example, what we do. We start thinking different in our products. We went to Japan. We came from Japan, and the big player there, they're looking for our product. When I say the big player, you can think about it, the big player. So we start small, and we said, can we use this, this product, for example, that PCB, can we use it for other products? So we standardize all the interfaces, we standardize the software, and we start building, from this, for example, we are building, what we call the PHMU, prognostic health monitoring. Existing airplane, you give them that, they will be happy. And you put it in your system, you certify it, you will say, this is a 150 million business. Another market, which is flight control computer, 2 PCBs inside with 2 dissimilar things, DSP, FPGA, whatever you want. And you have you can adapt it with any installation from the aircraft you want, with regard to altitude. And there is a EMI board here, there is a lightning board here, and it's a dual channel. And this is between 5 to 800 million business. And you can adapt it for existing market as well. So, and we start, building this, and we are like, getting to our 8th product today, starting from scratch, self-funded, using our, like, our own money for 1K, putting all that money there, we want out there. And in reality, what we are doing, we are sharing the market with our suppliers. And the suppliers, they are producing for our own designs. We design, the layout, we design the Altium, we design the PCBs, we design everything they produce for us. And we are bringing, that manufacturing and for the PCB as well to the US, right? So meaning like, we are taking the hard way, but absolutely the safe way. Building everything from hard and, hardware and software. To give you some analogy there, like, NVIDIA, they took the risk, maybe 20 years, 30 years, they used like, your chip. And now they are like a dominance of when we believe that the hardware is, is not a source of money. We are certifiable, like, day one, meaning, we help and support our customers, with documentations. And of course, like, we are highly integrated, product. Very quick, from our vision you have seen previously, electrifying mobility and smart microgrid, we design a bunch of products. We integrate them to create the systems, and after that, the systems, we are going to our next, you start the journey, and we found like a fantastic partners for us. They're gonna be our customers, by the way. They have the unique aircraft Part 23 in the United States, 2-seaters, and we are partnering together. It's a Liberty Aerospace. They have like, the XL2. So we're going to be converting the XL2 electrics, using like, a sort of basis of certification today. We can make like an amendment TC on that, STC on this, whatever it is. So you can see like, the verticality integration of our product in an airplane today, and they are absolutely great, to work with, right? So the foundation, what we call here, the foundation for the future. So what we build in reality, what we look like, you can see like any propulsion traction system today. It's electric motors, power electronics, which is the brain. There is a power distribution. It's your panel, fuses, conductors, SSPCs, whatever you want. And after that, you have a source of energy. It can be the battery, fuel cell, nuclear, whatever you want, as long as it's a DC side. And we are adding like the 2 boxes there, which, that boxes, we are adding in our like, certification as well, to prove that there is, in terms of safety budget and certification, we are covering every aspect of failure we can find in the airplane. We are, when we go to the FAA, we're going to go like, with the entire, like, design type. We know absolutely around, the layout, around, the software, around, how we certify that and how we test it, and so on and so forth. We are not giving, our control outside to supplier and say like, let's call the supplier. He's going to be, telling us like how he's testing, the product. We know exactly how the product operates, which is, I call it like, the bold, approach, but I think, the safe approach. You have seen it from the numbers previously. We are focusing on just make it work for 200 miles. Don't tell me like 1,000 miles and 3 hours and all. Just, 200 miles. If you have an electric airplane for 200 miles, we will understand. Why this? Because if you do it, you can create a supply chain. You can create like, the entire ecosystem. If you start big, you have the entire constraint and all the issues you can find. And it goes from the regulatory perspective to supply chain to anything. And even like, from the CapEx perspective, it's huge. So we are starting, small. From the aircraft, as we said, we are like, with the Liberty Aerospace team, Dr. Magomed there, a long experience, from Russia to the US. A big team, doing a lot of, aircraft, and CG as well, the CEO as well. They know the how they operate the aircraft, how they certify the aircraft, which is a fantastic, fantastic, like, place to be. Here I put, some Seattle to Spokane, and Seattle to Portland, and Seattle to, Yakima, and, we can see some miles there. Once you set up like in the first, the first product, I will say not complex, but yet complex, but easy, to build on the top of that. This is Liberty Aerospace. They have like, existing, XL2 aircraft. We are like, establishing a market in our presence, a strong partnership with them, and we will scale on this. Soon we're gonna sign an MO, with them, which is, a fantastic, place to be. We start really like, starting building this. Soon we're gonna get the airplane, here. In reality, maybe 2 or 3 airplanes, because we have some other places in the world they are looking for this business model. They want exactly to bring, that airplane there because it's a Part 23, start operating and we start, selling it. So this is gonna be like, it's gonna be our move to electrify the aircraft in the United States. And a lot of people are looking, for this product. In parallel, what we are doing, we are taking all this product and selling to others, using for their vehicles, for example, or their applications. This is the aircraft, of course, it's certified. When you put the electric, product on it, as we said, we are doing, the either like, STC, or you make like, amendment TC on the existing, certification data you have, but you are not starting, from scratch. From the certification, because it's costly and it's a long way to go if you start from really like, certifying aircraft from scratch, which is good. That will put United States as the first electric airplane soon. And hopefully you're gonna, as I told you, like, my son in Civil Air Patrol, he will fly this one. I promise him. So, achievement in 1 year. We started in January. By the end of the year, we had 4 products in the table. So just to give you an idea, like, that product, this one, is 3 years of development for other companies. And it's an aerospace product, completely can go to the aircraft. Why we did that? It's a lot of experience we acquired, along the time, but how they optimize our design criteria, how we manage, the configuration, what the data will bring, to the suppliers, how we work with the suppliers. It's a hands-on, like, really, really approach. So, and we were proud, like, by the end of last year, just to one of the customer in Japan, big customer, by the way, and we're not, we are like, in internet now. We did a meeting like in April. And we said, this is our approach. We're going to provide, 3 products by the end of the year, with his team. And he said, man, I mean, with all the money, like $40 billion, like, company we are, it's difficult to get to that point, but you are dreaming, good for you. We went to Japan with our product in our bag. We came to the meeting. I can tell you. He came with his team, and the first thing he said, this is the product, you talk to us? Like, yes, this is the product, the DOS product. And he said, let's sign a contract today to let you know the impact of the product when you bring. And wherever you're going to tell to people, they don't believe you, how much, strong you can, if you follow like, your gut and you see the truth. And we are signing like, 3 agreements soon. Maybe between 5 to 10 million, starting from 0. That's like, the product. Sorry, here it's the PDF stuff. We designed a motor controller, 75 kilowatt and 150 kilowatt. We designed a flight control computer, which is, Honeywell and GE market, and PHMU, which is a prognostic health monitoring. I call it the doctor of the family, gathering all the data, temperature, pressures, short circuit, current, voltage, and it will tell you like what's the lifetime of the product in your airplane, and who the first gonna die first. So you can see like, how you can make a proactive maintenance. So you reduce the cost of the maintenance, you reduce the, they anticipate a lot of failure. And if we gather the data and the nerve of the world today is the data you gather, you can put them, in a AI, model and you ask him, to just, to create the entire digital twin for your like, aircraft or your engine or whatever you want. A lot of patents, there. And just then I put some books very quickly for you. The 0 to 1, of course, inspired this great book. Power of Failure and Reality is done for like, GE. It's a great book. I really like, advise it. On leadership, they are very fantastic book. Reality to build like, where, to get the convection to my, like, things to start, where we started. I've read like maybe one, and once you go through, doesn't mean like you have to read everything. There are some few books you need to really learn to connect and to go through. And this is the formula. The reality, the happiness is the reality to over your expectation. So what do you expect from your life? And is there a reality in front of that? And this is applicable for everything you do. So you raise your expectations, in reality, happiness goes down because you're gonna be maybe very quickly like disappointed. And if the reality is never like you cannot like you don't have 10 million, you don't have 1 million. So the reality is all the time limited. You have just to deal with the equilibrium of this formula between your expectation and reality, and you will be happy. Takeaway. If I was like your age, honestly, as someone teach me like the entrepreneurial like mindset, I would like have I was doing like a lot of study, but going to where where we are today, but adopt that. So you are all the time open for new challenges. Don't be afraid about that. Make like an incremental progress. And just quantify your incremental progress or your progress each time you do something. Balance your happiness with your realistic expectation, of course. And the most important thing, believe me and trust me, is give time to others. More you give, more you will receive. Absolutely fantastic. And you do it, since you are young. Don't wait like when you are like getting to the certain point to start doing something and you start doing it. It's going to be difficult what we call the network today. So and there is a lot of studies from Harvard about the most successful people in reality, those they have this solid network. And network, it's how much you gave in your life. So give the time, give it's not like only material stuff. It's real to give time because we don't have time in reality. And thank you. Questions, go ahead, please. So
The accuracy of call it the doctor of the family.
yes.
Well, how accurate is that? Predicting heart failure.
Of course, the prediction will depend on the model you're gonna use, but in reality now we're gonna gather just like the data, right? So let's say you have electric engine, you have a 3 overspeed or 3 short circuit on it. From your physics, if you have a 3 short circuit, 3 over temperature in your winding, you have a high likely condition that you're gonna get like failure and catastrophic failure. Short circuit in the coil or like in the winding or something like that. If you have an overcurrent, 3 overcurrent, you can say current, like you can say, hey, this is a hotspot, something. So you gather all the data. Of course, the data of not really on its average data, not like a real time, but at least you gather the failure and you sync between that failure. So you start from that things you predict. Like your son, your staff, you have 3 times coughing. Hey, let's go to the doctor. There is something there. Temperature for 2 days, it didn't go down. There is like a virus or bacteria or something like that. So in reality, the prognostic health monitoring was given only for the big actors like GE, Honeywell stuff. They are doing this with your method. We are creating a standardized product. You can swap it. We are starting digital. So we are using the canvas. gather all the data. So sucking all the informations. After that, the data, the product, when you put it in your system, in reality, in the beginning, you don't have to take any decision with it. You give it to operator, you give it to your AI things, you give it, whatever, your neural network, and it will tell you like, 3 short circuit, 3 overcurrents, this motor gonna get like 50 hours. So you have to make like predictive maintenance, somewhere. Right. So today, like, what we are coming, we are expecting that thousands of operation hours will be enough to do the digital twin on this, right? In future, you will add this one in your system to be a DAL maybe B in your software from certification perspective. That means he can ask the brain to say, hey, you have to stop, you cannot operate. We are not doing that like in the beginning, but we're just gathering the data. In reality, what Tesla is doing, until like, maybe last year for 5 years, they were gathering all the data and removing a lot of you have heard maybe last year, like, the brake, they're removing the brake, right? So this is we call it the prognostic health monitoring, and it's between 100 to 150 million business. Please.
I'm really excited to see when you get the route between Everett and Spokane
There we
going.
go. There we go. There we go.
And yes,
Full-man.
absolutely ready for that. What, in your estimation, what happened with Aviation?
Aviation, the aircraft?
Yes, yeah.
Yeah. So we work together, and we have been, with the price, we have been even like, with it's a great team. They start off Israel, bring the aircraft, here, and there is a lot of variables. But I will say, from the technology perspective, as an engineer, we learn a lot from that aircraft, and I think it was a stop last week, 2 weeks ago. But for any engineer, it's a start of something, right? We burned the airplane, like, we were in Moses Lake. We have seen the airplane burning there, and the leadership at that time, pushed the boundaries to get, the electric, batteries and, fly with it. And it was tremendous effort. I was sad for the families, of course, but trust me, it's like, you are starting, hammering like, concrete, wall. You cannot make that whole. It's like steel. Aviation, they did the first maybe few stuff, and they're gonna be some other people. The 9-seaters and beyond, it's not like, dream. It's a reality, and we have to get to it. The problem of like aviation or others, when you start something, you need capitals, you need a longer, run, but as well like the supply chain. And trust me, the supply chain is a disaster. There's no, like, you go outside for like HVDC connectors, like, small thing, you don't have it. So it was a start, and we are taking that flag and starting, for 4-seaters. And one day we're gonna call Omer to say, or Craig, or the people that came after that, to say, we are going to that. You guess you have to join now. Yeah, good luck. Absolutely. Thank you. Jed, go ahead.
I have a quick question. What kind of motor is in these planes? Like, is it something you custom make? Is it something off the shelf? Brushless?
Sure. It's a good question. For the 2-seaters, 5-seaters airplane, we are talking about 75 kilowatt, 150 kilowatt. In reality, there is no electric motor outside. There is a lot of motors from Magniac, Zero Abia now. It's a 500, 600 kilowatt and beyond. They are all of them permanent magnet machine. So it's the quickest, path to get the motor, to get your propulsion, system. Or you go to automotive, and you take, YASA, you take, all that aspect, Amrex and things. In reality, it's a big risk if you take that, that airplane, that motors, and you start, to certify. I'm a believer of aviation and, certification of product, which is follow a lot of our processes, and I don't see like automotive, product can goes to plane. At least I'm not gonna put my keys there. So we are designing our own electric motor. There is reality, there is two types. We are starting with a permanent magnet to build the organization around it, the easiest one. And we are launching another technology of the motor. No rare earth there. You are not depending of any of country in the world. You are producing in United States, and the safety will go as crazy. You can monitor every short circuit on site. You can challenge every fault inside. You can cut and restart the motor. And this is a ZT1 proprietary technology. We are working on it now. It's a 75, 150 kilowatt, and after that we will try to scale it up to beyond. But the technology we'll see in a few years, it will be I would say whipping the entire market. Any other questions?
Currently, the designs that you're utilizing for your various products, are you personally involved in developing that, or is your team, or both?
100%.
Oh, it's you primarily.
With the price, yeah.
Oh, good for you.
100%. In reality, we are two. We designed 5 products. There is a company in India called, they are producing for us. But we design the schematics. We make the rating analysis. We make the MTBF. We make the certifications, stuff for every product we do. And this in reality, it's a fantastic, questions. Because once you do this one, you have a very high control what you can do now and when you can do later.
Speaking of doing it in-house.
Yes.
Oh,
Yeah. Yes. Definitively, we are doing absolutely enough. It's a long way, Ernest, because when we started, people was like, "Hey, you have to focus. You have to make one product."
mhm.
It looks like we have the capability to do much more, because the idea is to design more, create the volume effect, you reduce the cost, you give the visibility for supplier, so they trust you, you create a new market, and you sell that product for others, you bring cash into, like, it seems like,
Self-generating.
yes. And the idea is you limit the investors to your business as much as you can. If you don't do that and you are dependent on others, there is a lot of supply chain volatility today and problems. So we are doing, everything. And we are starting, we'll be producing here, like, in Seattle, all that products. And with the tariff, like, I get all this tariff and stuff I get from the health, some companies from the health, they said, can you produce for us? And we can provide 50 million.
Items.
$50 million,
dollars
if you
worth, yeah.
produce, if you produce for us.
Sure.
Meaning, like, when you do hardware and you do it, and after that, you just, you stick the quality, you stick, like, the health, it's FDA, not the FAA, but they are, like, almost, similar. What I'm trying, to say is, when you control the product ground up, you control absolutely better the market.
Well, that was Boeing's original intent.
Yes, yes, yes. And all that, last year we lost, like, that strategy and philosophy. So start, outsourcing a lot of things.
Sure.
But definitively, like, that compared to aviation, that's what we do, for example, like, compared to others, we are building, piece on piece, growing on this, selling a bit, going to the next step, selling, getting to the airplane. And when we get to the airplane, we set up, all the regulatory stuff with the FAA, set up the supply chain. And it's like, hey, what next now? And in meantime, we have a big success with people wanted to buy this product.
Mhm.
To say, hey, and they want, to create, like, we are about, to start, we get the first contract yesterday.
Congratulations.
Yeah, thank you, Ernest. It was, thank you. I thought to Bryce, he asked me this question this morning, if you sleep well? And I said like, yeah, starting from zero, yes, we for the first time, and it's overseas, and they are looking for like, our product for maybe 5 to 10 million.
Congratulations.
So, appreciate it.
Wonderful.
Thank you so much. Any other questions? Thank you so much for your time. Yeah, go
I
ahead.
got a quick question. So in terms of the motor, I'm curious because actually like an hour ago, I was teaching motors in my power class. So I assume like, like different for mechanical engineering, sometimes motor have different like a definition, but we're talking about electric motor, right?
Yes.
So if and for the electrification, what's like eventually we want to go to hydrogen powering. So does that mean you need another like hydrogen generator for supplying your power, supplying your motor?
So from the like, the schematics, if you see, like, the either proportional or traction, they are all of them the same, So the motor is like, electric motors, right?
Right.
You put the prop, to create the thrust. Before that, there is some electronics. The battery pack, there where the fuel cell or hydrogen can be as well, right? Like, you swap, or you can combine them. One of the customers looking to combine them. And 4-seater airplane is going to be fuel cell and battery, right? So how you generate, the power. And after that, you have just a set of conversion until you get to the motor. The motor has a mechanical, electric power coming from the power electronics, converting to mechanical. Right. And after that, you make a succession of how you can optimize the efficiency, the integration, the thermal integration, which is, the delta between, what we do and others.
Yeah, I was curious, like since we have the battery to the power and power electronic, I assume like your motor is running like at AC, but if that's the case, what's your like transformer frequency of that? Because I know on the airplanes, usually you don't run 60 hertz, you run like 400-ish like that.
Yes. So the frequency generator, it's your power electronics. Yeah, the motor controller. This is you bring the DC and you are making an AC side to the motor. Right. So this is the power electronics. We didn't bring it, but we designed that intelligence, like, bringing the battery, the DC side, 800 volt, 400 volt, converting to, alternating things. You are looking for the field, and you just, sync that field, to your stator field, and you run that. From the battery, the DC side is coming, we are expecting for the 2-seaters, the batteries. For 4-seaters, 5-seaters, we will add a fuel cell on the top of that to make it dissimilar power from the certification perspective, but as well, like, much more margin, because the battery will start getting to the point where you are much more heavy.
I see. Okay.
So.
All right. Thank you.
Thank you so much. God bless you guys. Thank you.